pleasure to present you some results of our study concerning the mechanical muscle oscillations in Parkinson patients without tremor compared to healthy controls. Firstly, the motivation behind it is that the diagnosis in Parkinson patients is mostly based on clinical examinations like the UPDRS. This is subjective, so there's a great need for the development of an objective diagnostic tool. It is known that the manifestation of motor symptoms only appear if already around 50% of the dopaminergic neurons of the substantia nigra are lost. So it is also known that the neurodegeneration must start before the motor symptoms get apparent. However, usually the motor output is rarely considered. Of course, the UPDRS also includes some motor tasks, but the objective motor output is usually not measured. And if at all, investigations are done with patients already having a tremor. But then it's not surprising that there are differences between Parkinson patients and healthy controls because of the apparent 5 Hertz tremor, which of course is also shown in the motor output. We thought on the one side, because also healthy persons show mechanical muscle oscillations around a frequency of 10 Hertz, and because the neurodegeneration in Parkinson patients already occurs prior to the motor symptoms or to the manifestation of motor symptoms, that it would be probably of benefit to look into the mechanical muscle oscillations, comparing Parkinson patients without tremor and healthy controls. So we hypothesized that the mechanical muscle oscillations show different characteristics between Parkinson patients without tremor and healthy controls in a specific bilateral motor task. The study was funded by the German Society of Parkinson and Movement Disorders and was performed in cooperation with a special clinic for movement disorders in Parkinson in Beelitz-Heilstätten. So what we have done, we measured or investigated 18 Parkinson patients without tremor and 23 healthy age-matched controls. All of them were investigated by the neurologists of the special clinic to exclude some neurological problems in the healthy group, or to exclude also the tremor in the Parkinson patients. All participants then performed a bilateral motor task, as you can see here. The hands were pushed in front of the chest against an interface, including a strain gauge to measure force and including an acceleration sensor. Each participant performed 5 trials at 60% of MVIC. And of course, prior to this, the MVIC was assessed in the same setting. We recorded furthermore the mechanomyography MMG, which sensors you can see here, of biceps brachii, brachioradialis, and pectoralis major muscles, and we used a piezo-based measurement system. And of course, we also recorded the accelerations and the reaction force between both hands. For evaluation, we firstly, of course, looked at the common parameter of mean frequency. However, since Parkinson patients did not show a tremor at this time, we suggested that there were no differences between Parkinson patients and controls. The second and uncommon parameter was the normalized variation of amplitude maxima. Since this is not known very well, I would like to to explain it a little bit more detailed. You can see here a signal of MMG, and when we zoom in, here you can see that the oscillations of a MMG signal is very clear and has a good signal to noise ratio. What we have done now is to calculate the differences between 2 consecutive maxima, and we calculate the arithmetic mean of all of those differences of one trial and normalize this to the maximum amplitude. For this parameter, we suggested that Parkinson patients would show a lower amplitude variation compared to controls, because a lot of parameters also different parameters show lower variation in several diseases. The third parameter was a specific power frequency ratio called MQL, which is totally uncommon, which we developed in the course of the study. You can see here the power density spectrum. On the x-axis, you see the frequency, and on the y-axis, you see the power. And what we have done now is to calculate the ratio of the mean of the power in the low frequency ranges of 3 to 7 Hertz and related this to the whole frequency range of 3 to 12 Hertz. So this should get an impression about the power or activity in the lower frequency ranges compared to the higher ones. And usually MMG signals are oscillating around 10 Hertz, so that's why we have chosen this frequency area. We suggested here that Parkinson patients would show a higher ratio because we thought that also in premotor stages, the oscillatory frequency would be shifted towards the lower frequency ranges, and that's why a higher ratio was assumed. Okay, coming to the results. Firstly, concerning the mean frequency, displayed is the 95% confidence intervals, including arithmetic mean and standard deviation of all oscillatory signals. On the left for the MMG of biceps brachii, for the MMG of brachioradialis and pectoralis major muscles, and on the right for the acceleration sensor. Parkinson patients are displayed in red and controls in blue. And what you can see now is that the confidence intervals are overlapping for the MMG signals, and this is supported by the significance. So Parkinson patients and controls are not showing any significant differences for the MMG signals for the mean frequency. However, and this was a little bit surprising, we found a significantly lower mean frequency in the acceleration sensor for Parkinson patients compared to controls. Usually a frequency around 13 Hertz would be considered as healthy. However, we do not know much about the behavior of the accelerations between both hands in this specific bilateral motor task. The second parameter was the amplitude variation, and again, you can see the same illustration of 95% confidence intervals, Parkinson patients in red and controls in blue. And it is visible now that all oscillatory signals show a significantly lower amplitude variation for Parkinson patients compared to controls. And especially for the biceps, the pectoralis major muscle, and for the acceleration sensor, the confidence intervals are disjoint, which speaks for a very clear significance. The last parameter which we have investigated was the power frequency ratio, MQL, and again, you can see the same illustration. And also, again, it is visible that the Parkinson patients are showing a significantly lower ratio MQL compared to the controls. And again, the confidence intervals are disjoint, which speaks for a clear difference between both groups. So coming to the conclusion, the results suggest that Parkinson patients without tremor, we always have to think about that the Parkinson patients did not have any tremor, so the results are even more interesting. So that Parkinson patients without tremor compared to controls in the specific bilateral motor task show at first a similar mean frequency, at least for the MMG signals, not for the acceleration sensor. The first part was according to our hypothesis. However, we did not expect that the acceleration would show a lower frequency for Parkinson patients. Secondly, the amplitude variation was significantly lower in Parkinson patients without tremor, and this was according to our hypothesis and is supported by several other investigations showing that in disease, different parameters are characterized by a lower variation. Thirdly, the power frequency ratio was significantly lower in Parkinson patients without tremor compared to controls, and this was completely opposite to our hypothesis. We thought, due to the premotor stage of Parkinson patients and to the later on developing 5 Hertz tremor, that the proportion of low frequency or of power in low frequency areas would be shifted already in premotor stages to the lower frequency range. However, the opposite was the case. So it seems like the Parkinson patients would prefer higher frequency ranges. And there are some investigations of brain activity which showed the same thing. And they assumed that probably in early stages, the motor system tries to avoid the pathological 5 Hertz tremor. And that's why he counter reacts and favors the higher frequency. So what questions remain? Of course, we have to verify the results based on a larger sample size because we only have around 20 participants for each group here. And of course, we have to look if other patients also show this behavior. Furthermore, and very important, is the question concerning the distinction to our other neuromuscular disease. So are these parameters or results specific for Parkinson disease without tremor, or can they be found also in other neuromuscular diseases? And we suggest that the amplitude variation might be unspecific because a lot of other researchers or investigations also show a lower variation in several diseases. But probably this power frequency ratio might be specific for Parkinson. And if this holds true, then there is the possibility to develop a supportive and objective diagnostic tool for Parkinson patients. And as you can see, it's really easy to apply. So it would be not much effort, and the diagnostic would be really supportive. And importantly, this also applies for premotor stages, because here the motor stage was not reached. So the differences were also found in premotor stages, and we hope that this might be a strong support for the diagnostic in Parkinson patients, especially because the treatment should start as early as possible. So here are my references, and I would like to thank you for your attention. And of course, if questions arise, please ask. Thank you.
Thank you. Thank you very much, Laura. It was nice to meet you in Italy. And are there any questions about this talk?
I start with just to know if I understood correctly. Therefore, you had a group of patients with the diagnosis of Parkinson in preliminary stage, I suppose,
yes.
that had no obvious tremors.
Yes.
Yes, and your results show that if you stress mechanically these patients, you recognize earlier than clinically evidences that they have problems in controlling. They have the tremor that even normal person have when they are strongly stressed, with a light stress, a lighter stress, a lighter. Is this correct, or is I misunderstood?
Well, principally, it's correct. So we had Parkinson patients without any motor symptoms at this time, and we stressed them due to this bilateral motor task, which might be pretty complex also for the brain, because both brain areas have to be connected and to work together. And usually these MMG signals, they are also apparent in healthy people, which we have seen. But as was visible, the oscillatory behavior of this signal, especially concerning the amplitude variation and the distribution of power in the frequency ranges, seems to change. Probably this might also be visible in EMG. I don't know, because we haven't investigated it, and usually those parameters are not investigated. They're pretty uncommon. But since every other investigation using EMG did not found differences, we have to ask if probably there's a need for different parameters to look at of those oscillatory signals. And of course, this bilateral motor tasks seem to enhance the probably also pathological patterns of muscular oscillations. Is the question answered?
Yes.
Okay. Thank you. Another question to this talk. Oh, so we have earned 4 minutes. Thank you, Laura.